Alright class, today I'm going to show you how to quickly take data and put the data that we gather into a pictograph. So say for instance, I went out into the world and I asked people what their favorite yogurt flavor was. And 3 people said they like cherry, 6 people said they like lemon, 12 like strawberry, and 9 like vanilla. So I have my data. I need to figure out what my scale is going to be, because when we make a pictograph, we know that each one of these symbols stands for something. So I'm looking at 3, 6, 12, 9, and I'm looking for a pattern, something that would make my pictograph make sense. So I can use multiplication, I can use division, or I can even just look at it and say, okay, 3, 6, 9, 12. I see a pattern of skip counting by 3. So I'm going to say that each of my smiley faces is going to stand for 3 people. And I'm going to take my data and I'm going to make a pictograph. So if 3 people liked cherry and one of these smiley faces stands for 3, I'm going to need 1 smiley face. Now if 6 people chose lemon and each smiley face stands for 3, I know that 6 divided by 3 is 2 smiley faces. I'm going to do the rest with strawberry and vanilla. So 12 people said that they like strawberry as their favorite yogurt flavor. If each smiley face stands for 3 people, I could even skip count to get to 12. So that's like saying 3, 6, 9, 12. How many smiley faces? 4. Gonna do the same with vanilla. 9 students said that they like vanilla. 3, 6, 9. So each one of these smiley faces stood for 3 students. Now, say that we do the study again and we find different data. Could really use an eraser. So say I do the study again, and instead of asking my classmates or whoever asked the first time, I ask my friends, and they say something like 10, 2, 15, 5. So I have 10, 20, 15, and 5. So this is my data, and I need to think, okay, what should my scale be for my pictograph? So each one of those smiley faces, or symbols, it doesn't have to be a smiley face, stands for something. So I'm going to look for a pattern between the numbers. Sometimes when I do this, I look for factors. So what do they all have in common? What can they all be divided by the same number? So I'm going to give you time to think about that for a second. So I see that each one of these numbers can be divided by 5. So I think I'm going to make my smiley face stand for 5 people or 5 friends. And then I'm going to use that key to make my pictograph. So if 10 people like cherry and each smiley face stands for 5, that's like skip counting 5, 10. So how many smiley faces? That's almost like saying 5 times 2 equals 10. I'm going to do the same for 20 students who liked lemon. 5, 10, 15, 20. That's the same as saying 5 times 4 equals 20. You guys catching the pattern? So 15 people like strawberry, 5, 10, 15. That's the same as saying 5 times 3 equals 15. And notice how this 5 is in every single column. All right, 5 people like vanilla. 5. Okay, I'm gonna leave you with one more problem to do by yourself. So say we do the study again. We don't ask our friends, we don't ask our classmates. Say we go out on the street and we just ask people what their favorite yogurt flavor is. And we gather our data, and we have to take that data and we have to put it into a pictograph. We need it to have a title, we need it to have a key, a scale, and the scale has to make sense. So I have a question for you. Why is a scale of 1 harder than creating a scale of more than 1? Why would I not want to use my scale as 1? Think about that. So my new data consists of, let's say, 16 people like cherry, 4 like lemon, 8 like strawberry, and only 2 like vanilla. I'm challenging you at home. You can do it on a piece of paper. If you have a whiteboard, ask your mom if you can draw on the table like we do at school. She may say no. And then I want you to decide what's the key, and then what's your pictograph gonna look like. And then send me pictures of what you do. Hope that made sense. Capiche?